Okay, welcome, ladies, to paper 2 chemistry. We're going to try and do the easier topics remotely. So by next year, we will go over it again, but so you actually know the basics. For those of you who don't recognize my voice, I'm Miss Pace. So hope you're all safe and well and having a nice time this Thursday morning. Okay, so this topic is called Chemistry of the Earth's Atmosphere. If you've got a copy of the spec, you can tick these off. This is the notes for the the triple spec, these codes, but it is the same content for the combined, even though the numbers will be slightly different. So just have a little look through your spec now, and you can just tick off the specification points. Okay, so your starter today is this question. This will be from the quantitative chemistry topic that you did. Just pause the video while you do your calculation. All right, so pause, do your calculation, and then start when you want the answer. Okay, so that's the answer there. I'm just going to show you how to do it. If you're not in my class, you might not be familiar with the table method. So feel free to do it using the method your teacher taught you, but I'm going to go through the table method quickly here. So just draw up a table. We've got 3 columns, mass, relative formula mass, and moles. Starting with 2 grams of hydrogen, what mass of hydrogen chloride will be produced? So we know the mass of hydrogen, so that's our known. So we'll just write that in our first column. We're trying to find the mass of hydrogen chloride, so we put that in our second column. Now, you do not include the number out the front. We only use that for the ratio, so just write the formula as is. So we know the mass is 2 grams for hydrogen. The MR, we've got 2 lots of hydrogens, so it is 1 plus 1. So that is 2. Remember, you include the little numbers, but not any big numbers out the front. Then moles is equal to M over MR, mass over relative formula mass. So we go mass is 2, relative formula mass is 2, so we get that's equal to 1. Now our ratio, we've got the big number at the front of here is a 1, and the big number at the front of here is a 2, so our ratio is 1 to 2. That means there's going to be twice as many moles of hydrogen chloride, so we go 1 times 2 is equal to 2. The MR, we've got 1 lot of hydrogen, so that's 1 plus 1 atom of chlorine, so that's 35.5. So that means that MR is 36.5. That's a 5, not a 6. And then our mass is equal to moles times MR. So that is equal to 2 times 36.5, and that will give us our answer of 73 grams. Okay, cool. So if you didn't get the right answer, go through my working. If you are still stuck, you can email me or you can email your teacher. Okay, so this unit is about how the atmosphere has changed over time. And it hasn't actually changed that much for the last 200 million years. The proportions are relatively the same. We have a little bit more carbon dioxide, but not that much. Not that much more. So approximately about 4/5. So approximately 80%, but it's actually closer to 78% is nitrogen gas. About 1/5, or approximately 20%, is oxygen gas. And there are a small proportion of other gases, which we call trace gases. So trace, and we say trace because there's very small amounts. So we've got carbon dioxide, water vapor, and the noble gases. So neon, xenon, helium, krypton. They're the noble gases there. All right. So here's a little video just summarizing how the atmosphere has changed. So watch it, take notes if you want, and just pause this video while you watch that one. Okay, so I'm going to go through what the video talked about in the detail that you need to know as part of your GCSE exam. So the Earth formed approximately 4.6 billion years ago, but it was very, very different to what it was now. So there was no water on the Earth's surface, and the Earth's surface was full of volcanoes. So it was very, very dry. It was very, very hot. The volcanoes were constantly erupting and spewing out lots and lots of CO2, but also small amounts of water vapor, methane, ammonia, and nitrogen gas. All right. So there was no plant and animal life. Earth was really, really, really hot. Next thing that happened was, one second. You can tell I'm bored, but the Earth cooled, and the water vapor condensed and fell as liquid water as rain, and that actually formed the oceans. So because of that, water vapor levels in the atmosphere decreased. Now, this led to a decrease in carbon dioxide levels because carbon dioxide can dissolve partially in water. So lots of the carbon dioxide dissolved in the water of the ocean. That carbon dioxide reacted with the water to form carbonate compounds. And these precipitated and formed the sediments that are on the ocean floor, which are known as sedimentary rocks, and the specific type of rock is limestone. So the rocks on the ocean floor are mostly made up of limestone, and that comes from the carbonates, which comes from the carbon dioxide which dissolved in the oceans. Okay, our carbon dioxide levels started to decrease even more when algae evolved first. They started to do photosynthesis, so taking in carbon dioxide to make glucose and releasing oxygen into the atmosphere. So this is when we first got oxygen in the atmosphere, and this was about 2.7 billion years ago. Then over the next billion years, we got plants evolving, and they also did photosynthesis, so took in lots of carbon dioxide to make glucose and made oxygen. So a little diagram there, carbon dioxide and water in, oxygen out, and of course glucose is used by the plant for growth, respiration, storage of starch, etc. Okay, so throughout time since we've had plants, the plants, when they died, some of them decayed. Some, in some areas, decay conditions weren't quite right. So we got layers and layers of layers falling on top of the rotting vegetable matter, and over millions of years, this formed our fossil fuels. So what we say is that the carbon dioxide became locked into those fossil fuels. because it's a storage of carbon dioxide. So the carbon dioxide is trapped in those fossil fuels. So eventually, after enough photosynthesis happened, there was enough oxygen for animals to evolve. And this started as very simple life forms and evolved to more complex ones. So this is a neat little animation here. So the evolution of animals, although animals do breathe in oxygen and breathe out carbon dioxide, it didn't actually change the levels that much. Animals have contributed to a decrease in carbon dioxide concentration because aquatic animals use carbonates to make shells. So the carbonates from the ocean get incorporated into their shells, which means there's more space for more carbon dioxide to be dissolved in the ocean. So just look at this little diagram here. Carbon dioxide dissolves, reacts with water, forming carbonates, and they're incorporated into the shells of the aquatic organisms. When plants and animals die, they are broken down by bacteria through decomposition. Nitrogenous compounds such as DNA and proteins, the nitrogen from them are released back into the atmosphere by that bacteria. So this is why we have considerably more nitrogen. Also, as soon as there was oxygen in the atmosphere, so after algae evolved, ammonia in the atmosphere reacted with the oxygen and released more nitrogen gas. And this is why we don't have any ammonia now in our atmosphere. So this here is just a little summary of how the Earth's atmosphere has changed. The dates, you need to know that the Earth formed about 4.6 billion years ago. At 2.7 billion years ago, that's when we first got oxygen because of the evolution of algae. And then over the next billion years, that's when we got the evolution of plants and therefore more oxygen because of photosynthesis. So you need to basically know a rough idea about the dates. This is just a nice summary of all the stuff from the slides before. So this is probably what you might want to put on a flashcard or whatever if you are revising. Now, this is a theory of how the atmosphere has changed. And we'll never be sure, and that's because 4.6 billion years is a really, really big time frame. So we have a lot of evidence. We have some evidence, but we don't know for sure. This term "locked in" is really important, and it just means that carbon dioxide from the atmosphere becomes trapped in sedimentary rocks or fossil fuels. So that is an important keyword there, locked in. So as you can see, compared to now, the concentrations of gases has changed a lot. So remember, the atmosphere used to be made of mostly carbon dioxide, and now it's only about 0.038%. It is increasing, of course, though, with the greenhouse effect and global warming. Oxygen, there was no oxygen gas at the start, and oxygen gas only increased when algae and plants evolved and started doing photosynthesis. So oxygen's definitely changed. There was some nitrogen in the Earth's early atmosphere, but there is considerably more now. And remember, that's because bacteria release nitrogen back into the atmosphere when they break down living things. And also, we used to have lots of ammonia, but the ammonia reacted with the oxygen and released nitrogen instead. So it has changed quite a lot over the last 4.6 billion years. Your little activity here I want you to do is just get a piece of paper, split it up into 4 sections, write down the 4 headings, and then just jot down the things that happened to cause a decrease in water vapor in the atmosphere, an increase in nitrogen gas in the atmosphere, a decrease in carbon dioxide. There are quite a few for this one, and an increase in oxygen. Just pause the video while you do this. Okay, ready and pause. Okay, here's the answers here. So water vapor, it decreased because the earth cooled and the water vapor condensed and fell to earth as rain to form the oceans. Nitrogen gas increased when ammonia reacted with oxygen, and when bacteria decomposed dead plants and animals, releasing nitrogen. Oxygen increased after plants and algae evolved and did photosynthesis, and carbon dioxide decreased when it dissolved in the ocean, formed carbonates, and got locked in. Remember, locked in, that keyword, locked in. Excuse the bad writing, locked in. Oh, that was really bad. Anyways, you know what I mean there. It also got put into the shells of aquatic organisms. It decreased a lot because of photosynthesis, as plants and algae take in carbon dioxide to make glucose and oxygen. And also remember, when the plants died but weren't fully decayed, the carbon dioxide got locked in to fossil fuels. This is a little revision from biology, but also it is part of the chemistry spec as well. So just write the word and balanced chemical equation for photosynthesis. So just pause the video and just jot that down on a piece of paper. So 3, 2, 1, pause. Okay, the answer's there. So carbon dioxide plus water using energy from the sun in the form of light gives you glucose plus oxygen. And then 6 CO2 plus 6 H2O gives you 1 molecule of glucose plus 6 molecules of oxygen. Remember, that's an endothermic reaction because we're putting in heat and light in order for our products to be made. This was just straight from the spec. So remember, algae did photosynthesis first, about 2.7 billion years ago. Then over the next billion years, plants evolved, and the presence of oxygen increased gradually until there was enough that led for the evolution of animals. We're just going to finish today's lesson with the question. I changed it for not 2 of the gases, but 3. So pause the video and write down your response. And then here's the mark scheme. So probably need to have at least 2 points for each gas. Carbon dioxide, of course, is the long one because, yeah, there's quite a few points there. Just notice here that this word locked up, you need to use the right keyword there. Okay. All right, so give yourself there a mark out of 6. If you're unsure, feel free to email me your response and I'll have a look there. So your task for today, for this lesson, first of all, I hope you've been going along and doing the activities as you went through the PowerPoint, as you're asked to do. So that was the exam question, the table, the starter, etc. I want you to summarize the evolution of the atmosphere in a form which makes sense to you. So you might want to do a poster or a flowchart or a TikTok. And I'd like you to upload a picture of this, or if it's TikTok, the video, into the folder for the assignment. Please complete the Google quiz attached so I can mark and give you some feedback. I also think probably complete 2 Seneca tasks from previous topics to make sure that you are revising the old topics as you go along. So hopefully you enjoyed that lesson. If you have any feedback on how can make them better, please let me know, and hope you're having a nice day working from home. Okay, bye.